Okay, let's see. On. Oh, it's favorite. Oh, thanks. Hey. Oh wow, that was perfect. That was perfect. That was perfect. I could do Star Wars. Yeah, I could also I could also do Star Wars, whatever that means. In the same sense that I can do Harry Potter. Star Wars? Okay. I am goated. That is a sentence. I understand that sentence. And I appreciate that sentence. Okay, needs some work. Needs some work. I have to practice a little bit more. Have to practice. Okay. Okay, folks. All 8 of you. Let us begin today's wonderful lecture. What the heck is this? Some music in here. Oh, hey, Gath. Gath is an excellent organic chemistry. That's the scary kind. So go check out Gath. You'll learn, literally, you could just learn organic chemistry. You just go there regularly, and she's teaching a course. It's insane. And the course is way better than anything I could ever come up with. My disorganized garbage math courses. that my students have to suffer through. Got organic chemistry issues, which everyone does. Check out Gath for sure. Insane. Okay. So, class. I hope you're all here. Because there's 8 of you here. Can't really trust this number, you know? Like fake news. So I don't know how many people are actually here. But class, if you're gonna watch it on YouTube later, it's important that you understand something. All right, class? Whoa, what is that? The subject is going to shift away from integration techniques starting at the end of this class. Is that understood? We will be changing topics to a marvelous topic, a more conceptual one. It's gonna no longer feel like just rote mental gymnastics, which this first part was. It's gonna be more conceptual, beautiful, mind-boggling, starting at the end of this lecture. So this is the end. This lecture represents the end of integration techniques. All right, here we go. Finally, that's definitely what I want to hear. Yeah. Okay, yeah, classic. This is typical class, dude. Oh my god, this triggers me. What the hell? All right. Okay. Okay. But what I want to do before we move on, before I dive right in, I'm going to do this problem. I'm just going to do this problem to show you what can happen in our latest stage of partial fraction headache. Okay? I just want to show you this problem. Before I do though, before that, I want to just talk a little bit more with my students. You know, I don't talk to my students that much these days because there's a pandemic. But here, you know, I'm just gonna sort of get to know my students and ask them what they think partial fractions is all about. Let's see what kind of a job I did as an educator by tuning in to my students. All right, so hey students, hey generals of Discord, please assemble. Okay, we've got Rack. Rack is like Secretary of Defense basically, and then we've only got Rack, so that's awesome. All right, so oh hey, finally some people showed up. Cots is no longer playing Albion Online or whatever that was. Shrek is here. Space Cowboy. B is here. Grin. By the way, class, certain people, which will be unnamed, approach me and tell me things are going badly. Like, hey, maybe you should have a practice other version button in WebAssign. You incompetent professor? And I like look at them and I'm like, well, thank you for notifying me. And then I changed that. And Grin is one of these people. All right, so you got to be grateful. These generals, they really keeping us safe out there. All right, so I'm going to go talk to generals and I'm going to ask them, what are the basic issues in partial fraction? Tell me about partial fraction decomposition. What's it about? How do you do it? What comes up? What are the stages? I'm going to see how much did I educate my class. Look at this massive list of generals. There's a whole 8 of them out of my 33 element class. 33 member class. Okay, let's go. All right. Somebody. Anybody. Talk to me. Tell me, what is partial fractions all about? And we're going to make a little word cloud. Let's see.
Break apart the bottom into its components.
Okay, break bottoms. Okay, I heard break bottoms. Okay, what else? What else is in your brain?
Set the inside the integral equal to a over one factor plus b over another factor.
Okay, something like this is in your brain? Yeah? And what else? What is the overall situation?
Simplify the problem into easier parts. Just integrate.
Yeah, exactly. Simplify integral of a crazy fraction into better plus better plus better. Does this make sense? Is this what was in your brain? Whoever just spoke up? Shrek.
Yes.
Shrek. Yeah, Shrek. Okay. And does partial fraction decomposition, is it used for every integral in the world?
No.
No. So what kind? Maybe that's in the word cloud. Yeah, use a fancy word. Use it. Just use it.
Rational fraction over or rational polynomial over rational polynomial.
Or a rational
Where
function.
the-
Yeah, one rational
Yeah,
function. Yeah. Integrating rational functions. And why are we integrating rational functions? Crickets. What is our overall project in this whole integration techniques game?
Break up the integral into multiple integrals that are easy to solve.
Oh, wait. Hot tamale?
Yo, what's good?
Your volume. Okay. Your volume's really low. Hold on. Hot tamale?
Yeah, you need to break the integral into multiple integrals that are easier to solve.
That's right. And what's the universe huge large scale intellectual endeavor that integration by parts is one small part of?
Can you repeat the question? I'm sorry.
What is the grand, huge galaxy brain, large scale endeavor, intellectual pursuit that partial fractions, integration by parts, substitution this and substitution that, and this kind of this and that kind of technique? What is the overall activity that we're interested in?
Make integrals that seem like they cannot be solved into integrals that can be solved.
Oh my god. Hot tamale coming in hot with the tamale. Oh my god.
I stole
Abs-
my roommate's microphone for this. Woo!
A little too hot there. Okay. So the mega grand pursuit is represented by this. Now, hot tamale, what do I put in this huge circle?
A little tiny dot.
And what color is that dot?
Blue.
Blue. How big is that dot?
Tiny, tiny.
But also bigger than you initially think, right?
Yes.
Thanks to certain tools that we have discovered. Does that make sense?
Yeah.
And that's the grand story. How little do we know? But like, really, is it pretty good? Is it decent at least? Yes, it's decent. We can tackle all integrals of fractions using the technique of partial fraction decomposition. We can tackle things with square roots and some certain kinds of expressions in them, thanks to integration technique called whatever, trig sub or whatever. We can tackle products if we can tackle individual pieces, thanks to something called integration by parts, which is not partial fractions, even though they have the same 4 letters in them. They share letters. We can do stuff even in this blue dot, and that's what we learned. That even with hundreds of years of geniuses giving us tools, you know, we can do certain things, but at the end of the day, it's a small pale dot, and that's humbling, but also fulfilling at the same time. So that's the whole large-scale situation with the first phase of the class. What the hell do we know as far as integration goes? And what are the techniques that we can use to navigate this small blue dot? One of them is partial fraction decomposition for these kinds of situations. Fractions of polynomials. Awesome job, generals. Give yourselves a round of applause. Are you clapping? Woo! Turn that volume down. Oh my lord. That. Okay. All right. I'm gonna get out of here. This is just a disaster. Okay, good job, guys. All right, I'm gonna go do this integral problem. So go write this down on your note cards, okay? All right. Okay, let's start this music again. All right, folks. I'm gonna do the last PFD for you, and then I'm gonna make a memorandum and a briefing, top secret, where I summarize what to do when you face a rational function. Okay? Awesome. Battling Storm 4, yes. The void is bigger than you think it is. Yes, absolutely. Okay, let's go. Here we go. Look at this. I'm gonna move this. Are you keeping track of it? It's right there. All right, good. Here we go. Let's do this. And note, step 0. Use eyeballs. It's a rational function. Notice that. Okay. Oh no. Step 1, I guess. Or whatever step you call it. Step. Big top. Big top. Long divide. Let's see. Long divid. Don't admit errors. Just, that's what we learn, right? These days. You never make a mistake. Long divid. Okay, you put the... Boom, big one, big. Make it big so you can see it. Okay. X. Subtract. Keep going. Keep going. -2. Big minus sign. Parentheses. -2 times my thing. Subtract. Plus 4x. No, no, no. No. No, no, no. Plus 4. Done. Remainder. That's the remainder. I can't go further. I got a small thing now. It's too small. So, x cubed over x squared plus 2x plus 2 is quotient x minus 2 plus the remainder 2x plus 4 all over x squared plus 2x plus 2. Good. Long division complete. Step 3. Or whatever. Step 3. Replace, replace, replace. Okay? And notice, easy, hard. Boom, easy. Save this. Okay, I've copied it. That's for later at the end. Make sure to add it. Awesome. Focus. Focus. Here. On this problem. Step 4. Figure out this integral. Boom. Focus. Hard focus on this. All right? Okay. It's proper now. So we're in position for partial fraction machinery. In position. Okay, we're in position to execute PFD. Okay. Factor the bottom. Break the bottom. Break the bottom. Okay? Try. Try. Okay. But there's an issue. Interesting. The bottom has discriminant, meaning b squared minus 4ac from that song that you sing. The thing that you got to take a square root of to figure out where the two x-intercepts are? Yeah. This thing? Look at it. You can't take its square root. This parabola, floating in the air. doesn't factor. Can't possibly factor. This is an irreducible quadratic polynomial. Okay? So, partial fraction doesn't let you crumble this further. That's an issue. That is an issue. That sucks. Okay? So now I'll show you how to deal with this. But look at it. It's a weird one. Meaning, it's not like your favorite kind. It's not like, for example, x squared plus 1 or x squared plus 4, whatever your favorite ones look like. X squared plus a number, positive number. X squared minus a number, that factors as a difference of squares, you know? But x squared plus, it's not going to factor. And you can see that if this was in the denominator, your brain would be screaming arctani, arctani, arctani. But ours is not like that. So I'm going to bring us to this situation. So this is the lesson I want to teach you with this example. It's a weird one, but with the power, with the unlimited power, of substitution. We can get there. Get to this arctani world. I'm going to show you that. Okay, let's go back here. X squared plus 2x plus 2. It's called completing the square. It's x plus 1 all squared plus 1. Complete the square. That's a true fact. In general, look, where did I get this 1 from? This is a reminder how to complete the square. This 2, I cut it in half. You always cut that one in half and you put it there. Square that, and then see what fudge factor you need to get a total of 2 in the constant part. You'll get a 1 squared when you FOIL the first part, and you got to compensate by adding one more 1 to obtain that 2. Let's complete the square. But now, the completing the square motivates the following substitution. U equals x plus 1. And so du equals dx. And now I'm going to transform this integral into u's. Okay? So I've got 2x plus 4 over x squared plus 2x plus 2 equals, the bottom is u squared plus 1. That's how I made up u, to make the bottom look like u squared plus 1. To get in the arctani zone. I want to get to arctaniness. Okay? Now what happens to the top though? Let's just figure that out real fast. 2x plus 4. Okay. 2x plus 4? How to translate that? X is u minus 1. So 2 times u minus 1 plus 4. This is 2 times u plus 2. And remember, du and dx are the same. So boom. Everything's in terms of u now. And in u's world, we're definitely close to arctani. So now we got to do this integral. We haven't done the integral. Let's go do it. All right. So when you have this situation, arctani bottom, linear top, you break it into boom and bam, or whatever it was called. Boom, bam. Boom it and bam it. Okay? Boom and bam. All right, so let's do that. Boom. Substitution. Let's substitute b. b equals u squared plus 1. What is b for boom? What is db? It is 2u du. Do we see 2u du in the thing? We definitely do. Du. Do you see b? Yeah, definitely b. B substitution. Yeah, why are you attached to the letter U? Have you ever asked that? It's kind of weird. All right, B substitution. Boom substitution. All right, let's do that. It's just 1 over B, dB. And this, ln. Respect number 1. Respect number 1, u squared plus 1 is b is u squared plus 1. Respect number 2. Done. That is the piece. That's called boom. That's boom. But what about bam? Integral of 2 over u squared plus 1. Okay? Bam. Arctani. This is an arctani integral. Just straight up. Respect. What was u? U was x plus 1. Bam. So boom. plus bam plus copy paste. Boom. Done. Okay? Lesson. Not all irreducible quadratic factors look like the one that's situated for perfect arctan manipulation. But after a little bit of completing the square, you'll get to that situation. And completing the square, you package into a little U substitution to your advantage. Fantastic job, guys. A round of applause for everybody. You know, class, I purchased some stickers from this notability thing. So let's go. Let's give yourself some stickers here. Here you go. There you go. Round of applause for my class. Okay? This was 50 cents or whatever. So I'm investing in the class. Okay. What a ripoff. Okay. Next. I'm now going to summarize what happens in every single PFD situation, in all the situations. All the situations that you'll ever deal with in homework, okay? Fine. Which is basically all the situations. Okay. Summary. You face an integral. Okay, blah, blah, polynomial. I'm gonna do an example, okay? I'm gonna just try I'm gonna run an example for you. Irreducible quadratic times x minus 7 squared times x minus 8 dx. You face this terrible enemy in front of you. Step one. Is blah small? If not, long divid. Never admit mistakes, folks. Long divid. Okay? Good. Next. Easy part, just do it. You're gonna get an easy part, then you're gonna get the hard part. Take hard part and apply partial fraction decomposition. The miracle of PDF or some PFD. Okay? Each situation has its template. For us in this example, I'll show you the template. Okay. So you're gonna have your fraction. I just called the top hard because it's not the same. It's not the same as blah. It's gonna be whatever comes out of the at the remainder part of the long division. Okay? Equals. Here's the template. You gotta have a linear term in front on top of this. Then x minus 7 is squared. So you're gonna have c over x minus 7 plus d over x minus 7 squared plus e over x minus 8. Okay, step 3. Follow nose. Tease out A, B, C, D, and E. The miracle is that it will always be possible to find these, and there will only be one answer. There will be a particular A and a particular B and a C, a D, and an E. Very delicate. That makes this crumble happen. That makes this trade-off happen. That's the miracle of PFD. It's a marvelous thing if you sit and think about it. Okay, follow the nose. There's some humor in here. A little bit of humor. Tricky trick. Funny. Plug in times times both sides is in here. Tricky trick, funny, plug funny. Plug in 0. 0 happens. You can tease out A, B, C. If you have no fancy tricks, compare coefficients, which I did last time. Okay, that's always available. Try to compare left-hand side, right-hand side coefficients. Okay? You get your A, B, C, and D. Step 4. Be a trader. Trade difficult integral or 4 easier integrals. Trade hard integral for 4 easier integrals. Now they're easy for me, but you might need a little more practice. Each of the types of integrals you have will crumble from the following combination of techniques. Just ordinary Chizonin style, old school. Substitution might help. Boom, bam, plus arctan. Or just obvious Eleni. Step 5. Add them all up. Circle answer. And highlight it using purple highlighter. Okay, done. Step 6. Marvel at how far you've come. All right, thanks to me. Okay, awesome. Oh God, no. Young's Lab's here. Oh, but Open Set is also here, so those cancel out. Open Set, awesome. Also Young's Lab, awesome. Awesome educators. Go check them all out, folks. Professor Peter, great luminary, way better professor, can explain things properly with the right words, like not boom, bam, and arctani. Okay, he'll tell you what it actually, like what it is, okay? So go ask all your questions to Professor Peter, and he'll make a respectable, good citizen out of you. Here, you'll just learn a bunch of garbage, okay? So there you go. Shout outs to everybody. All people get shout outs. Awesome. So, class, do you need me to write this in a classified setting? Do you need me to write this so that other people can't see it? Or is this good enough for you? Class. Oh, there are students, but not many. But some. Oh, you're talking to someone. Okay. I'm good. Okay, good. Good enough? Good. So you don't need classified information. Okay, good. I'm okay. Good. Good. All right, awesome. So look, it's 12. It's 12:12, folks. I will have office hours today at 6. We can do any homework problem you want. I can address any loose ends that you need me to address. I'm happy to. Office hours today at 6. Class. Six over here, okay? So your homework, which consists of partial fraction, but also like a review of all integration techniques, because today's the last day of techniques. We can just go and try, just go out with in a blaze of integration tonight in office hours. You can do the homework with me. You can force me to do all your homework. Of course, I will give long-winded, very boring answers. So, you know, that's the tax that you pay. I'm not just gonna answer things one-liners. So there you go. I will always teach and preach. Okay, so content for today done. Seismic shift in content coming up, okay? Wow. Okay, awesome. All right. Get that music back playing. Okay, so let me tell you the next topic that I'll start on Friday. And Friday and Saturday's homework assignment will probably get shifted. Definitely will get shifted to some later date. So Saturday's HW will get shifted. Will get kicked from somewhere next week. Don't worry. I'm not a lunatic. All right? Okay. So what's the next topic? Okay. One sentence summary of the next topic. Okay. So what was this? Okay. That? Oh, I have one sentence. So there's a lot of commas. This says there's an up here, there's commas. But what if? Crazy. What if you have a shape that goes on forever? Can you make sense of this integral? How do you compute them? Why do you not always only get infinity? Is it always infinity? The answer always infinity? No. It's an amazing, mind-boggling lectures coming up. The next couple lectures. It's first exposure to the beauty of infinite calculations, infinite shapes, infinite-looking integrals. They don't look like they're proper looking. They are improper. Improper integrals. That's what we're doing next, folks. Okay. Okay, no. Here we go. Let's look at. Okay, lots of requests. Shungite. Yeah, today was a heavy. Wow, double dose of Shungite. 1, 2, 3. 1, 2, 3. I just canceled the first one because counterclockwise and clockwise are opposite. They have the opposite right and left hand rules, so the Shungite fields cancel. And
yes, science.
Something about the radiation.
Yes, science.
Okay. Teacher's pet. Dr. Young's lab is teacher's pet. That's one of the worst teacher's pets that I could ever ask for. Unfortunate. What a waste of the teacher's pet redeem. Students, you need to get on this. Because if you don't redeem the teacher's pet, we end up with a Dr. Young's lab type person. Which we know what kind of person that is. Okay, B-Boy wanted to hear some recorder. And with the recorder, we'll wind down this garbage stream. Okay, so where is B-Boy? Are they gone? They probably already left for, whatever they do. So, B-Boy just barely comes to school in the first place, so why would he stick around? Okay, well, I mean, B-Boy, if you have a request, then you might as well make it. I'm probably not going to be able to play whatever you request, but imagine going to school. Yeah, okay, yeah, see? Flight of the Bumblebee? Yeah, classic B-Boy. Okay, he wanted Flight of the Bumblebee, okay. I can't play the chromatic scale, so you'll just get like a bunch of notes in like the major scale that go up and down in the roughly the right relative position. Okay? Can you get that on Spotify? Who is this Agathon? You're new. You're new here, and you haven't earned the right to make fun of me. Who is this Agathon? Who is this? Who megalul is this Agathon? Welcome, Agathon. I'm glad you're here. Okay. What's my SoundCloud? Okay. Flight of the Eardrums. Oh, I'm sorry about that. I am sorry about that. Okay. Okay, let's see. Good. It's interesting. None of my students were playing video games during class. That's an improvement. Okay, Crow. Crow has redeemed recorder. What does Crow want to hear? Hey, basketball's in the news, right? Isn't basketball in the news, folks? Isn't there like a lot of basketball happening? I guess not, but I'm telling you, students. Oh, these are math students. They don't have lives. Okay, students. There's a thing called basketball, and there's like it's like a game where you put a ball into the circle. You know, like unit circle, and it's a game, and you play it outside in the outside place, outside the library. Students, you can go outside the library every now and then. Okay, so anyway, it has a song. Basketball has a song. Okay, here it goes. Ready? Here it goes. Okay. Biotech Nick wastes their money and subscribes. There's nothing in this channel, Biotech Nick. People don't subscribe. There's not. I don't have emotes. I don't have anything. So, but thank you for expressing your support, Biotech Nick. That's insane. Literally insane. Like bad financial decision. Email? Oh, let me check my email. Let me check it, Tori. Let me check right now. Make sure I'm not... Let me check your email. Let me check my email. Okay. Let me do some... Let me hack into the mainframe here. Okay. This... that. Okay, no email there. Maybe it's on Canvas. Let me go check Canvas, folks. Is it on Canvas? No, I don't have your email. So that's that. Okay. That's right, Crow. That's the kind of, but that's what I have to deal with, Crow. That's the kind of students I get, you know? That's just my, I wish all my students were like Rack, or like Grin, or like Macaco, or like Chizonin, or B-Boy, or Battling Storm, or this person Burger Man. They seem to be Dan, or like Math Mama, yeah, or Hot Tamale, definitely. Flushed Throne, Pokemon Lover. I just wish all of them were like that. Tots showed up today, but no, most of them are like those people. Oh yeah, don't yeah, Tori, don't you know? Yeah, don't finish that. Don't finish it. Don't. Tori, talk to me on Discord. Tori. No, Tori. Okay, I gotta go change all my bank account passwords and everything. Thank you, Tori. Okay, that's yeah, I gotta secure my recorder. I've gotta put this in a safe now. I have to put this in a safe, Tori. I can't just let it hang out. I've gotta put all my medical devices away. Very expensive. We will be using this on Friday to look at areas under curves. But will it be here on Friday? Someone probably will have stolen it by then. Thank you, Tori. Okay. Oh, Perrier King. Thanks for following. Biotech, thanks. Oh boy. Next, Elon Musk. Real? Real. Thank you, next Elon Musk, for following. That's big. Big if true. Rohit Kumar, thanks for following. Alright. Okay. That was ages ago, so those people are gone. Really good streaming technique. Okay. Alright, folks. Go get some energy, nutrients, steady the mind. Come back for office hours. We will go over homework. There's a homework due today. Let's go over it. Let's get your confusions, whatever, however big, small, let's get them out there so that everyone can benefit and so that I can make fun of you. All right. B-boy, keep puzzling, keep asking. Yeah, keep B-boy. Ask that question all day. Today? Tomorrow? What the hell could he mean by this integral? What does he mean when he puts an infinity as one of the bounds to compute the area? What? Keep asking that out loud in public, B-boy. The more you ask it, the more you'll appreciate how awesome the next 2 or 3 lectures are. Not just because my lectures are awesome, but the content, the mathematical content is mind-blowing, especially if you're seeing it for the first time. Yeah. Okay, well, let's see. Where do you guys want to go? Let's see. Let's go see. Okay, you're not supposed to raid the same place twice, I learned. Oh, wait. Who's out there? Let's see. I gotta send you all out there and then move on with my life. Yeah, I don't know who's out there, folks. Oh, educational, you know? Uplifting, positive person, like me. Clearly. Okay. Diatom's attack. Yes. Diatom's attack. Diatom's attack. Let's go check out the microscopic world. And folks, we know about microscopic things. For example, folks, only my class understands this picture. But the picture is worth 1,000 words. All right, class? Notice that the sum total knowledge of humanity is microscopic. But it's still pretty big. Thanks to the work of brilliant mathematicians who have given us these techniques that help us crack a couple problems here and there. But it's still microscopic. But you want to go see a real microscope? Let's go see it. Diatom's attack. Here we come. Start this raid. Let's go, folks. This is going to be fun. Go check out microscopic things. See you later. The raid happen? Did this raid happen? I'm not sure. Am I done?